So, our collective understanding of innovation is wrong. It may seem at first like innovations are introduced by a single point of light, a lone person having a eureka moment. However, we can see that for any major innovation, this is just simply not the case. For instance, let's take the story of who invented the computer. It may at first seem linear, like a single event and implementation was the start. However, it was not one but many steps forward. Maybe under certain definitions, it was the ENIAC, widely regarded as the first electronic, general-purpose digital computer. There were other computers that had these features, but the ENIAC had all of them in one place. But that said, it wasn't binary. Colossus is also regarded as one of the world's first programmable digital computers, although it was programmed by switches and plugs. Binary being pretty important, maybe we want to trace it back to Aiken's Mark I, but it wasn't electronic, or however, Z3 and Z4 were the first programmable computers. Atanasoff and Berry designed the first time a computer was able to store information on its main memory, but none of those would be possible without Claude Shannon and Turing evolving theory. But none of this would have been possible without Jacquard's loom or Babbage, who created mechanical calculators, or Ada Lovelace, who invented the concepts of modern computers. She thought about how abstract anything, not just numbers, could actually be something that a computer processes and uses, and actually invented software programming. But then it really does depend on your definition of a computer, right? Because maybe you're talking about the computer chip. The computer chip is a major part in innovation of a computer, but didn't come until way later. Or what about the first prototype of a GUI and mouse? And really, what would modern computing be without the development of Ethernet to connect multiple computers and hardware? As Matt Ridley says in How Innovation Works, the invention of a computer can no more be pinpointed into a single point than you can pinpoint the moment a child becomes an adult. For even with all of these pieces, it's not just one trajectory that these innovations were made. Some were theoretical, some were hardware, some were software, and different types of innovation pushed this concept forward. And thus, what we see is that innovation is a system. It's a series of interconnected frequencies. Innovation is connections. Innovation is a network. Yet many people talk about innovation as a single point of light, a light bulb turning on, an aha moment that strikes only the most brilliant of all creators. But even the light bulb was invented simultaneously by 21 different people in different parts of the world. Edison might have gotten that final patent over the line, but the invention of the light bulb was slow, cumulative, and inevitable. Innovation is not a singular eureka moment. So what does it take to make something new and useful out of things that existed before? How do we create a seismic shift out of things that existed? We often talk about the waves of JavaScript frameworks and other areas of open source, the single moment in time where a framework hits massive relevance. But we don't talk about what makes a wave. Waves aren't created on their own. They are created by a force of nature, the wind. And so today, as we talk about innovation in the industry and in open source, we're going to talk about the wind and the waves. I'm Sarah Drasner. Anyway, so who am I to talk about all of this stuff? Back in the day, I was a React developer. I keynoted React Rally and then some other React conferences. And then I became enamored with Vue, and I got really active in open source in the Vue community and was asked to become a Vue core team member. Then in September of last year, I took a job as director of engineering at Google, where I run web infrastructure. So that includes, but isn't limited to, JavaScript and TypeScript languages and libraries, Sass and CSS, web testing, including Karma, and a few frameworks, one of which is Angular. I don't personally run the Angular team. You can think of me more like Angular's grandma. But I did get involved in all of these open source communities from different points of view. And so today I'm going to focus a little bit on Angular. But no, I could still tell this story from the perspective of focus of any number of frameworks, as the point is that we all learn from each other. However, I do think what's unique and intriguing about Angular is how it stood the test of time. It's shaped and influenced multiple JavaScript waves in ways that I think people don't fully realize. And it, in turn, it learns and grows from, and is continuing to grow from those around it. So basically, when I see other frameworks thriving, I really feel happy for them too. Which leads me to, how do we get here? And how did Angular play a part? Now, in order to see where we're going, we're going to glance back at the past, at what I mean by JavaScript Framework Waves. But I'll warn you, this is a contentious area, so folks might not agree on all of these points. So remember how I said that innovation was more like a network or a system than a single aha moment? Remember how I said that Angular stood the test of time? None of these frameworks were made from thin air. So we have all of these different waves and even precursors between them. So in the precursor section, that's not what I would define as a modern JavaScript framework, but they did influence each other and also the JavaScript frameworks. So from here, we have AngularJS, which was the first version of AngularJS, which was inspired by Rails in terms of MVC approaches, and also jQuery for some of the way that it manipulated the DOM. And then from there, we have Ember, also in this first wave, drawing inspiration from Rails as well, and Handlebars, which Yehuda Katz, who was a BDFL for this project, worked on previously, and AngularJS SPA capabilities. Then we have Backbone. Angular learned from Backbone, and Backbone learned from Angular, and also Rails MVC approaches. And Knockout learned from Handlebars and jQuery, introducing important concepts like computed properties. In the second wave, we have React, drawing from AngularJS, but dropping the M and the C out to focus on the view layer only. It was inspired by Backbone and also Redux, which was heavily used in the first version of React, where state management was inspired by Elm. The second version of Angular obviously drew inspiration from the first, but also from React. And Vue drew influence from literally everywhere. So we have computed properties from Knockout and view approaches from MVC from React, and we have a lot of the different HTML bindings from AngularJS. And then Svelte simplified much of what came before it, but actually started leaning more heavily into the compiler, which everyone is starting to get really excited and inspired from. So you'll notice I haven't told you my bets for this third stage because I'm not a weatherman. I will note that meta frameworks like Next and Nuxt have really picked up steam, and they've become quite popular. Solid.js is doing really interesting things in this space that a lot of people are kind of learning from and growing. And lastly, I will say it is kind of impressive that Angular survived multiple waves. So some of the things that you might not realize that Angular developed, because the waves in the sands of time tend to erase these things, are SPAs, first-class usage of TypeScript, test integration in Harness, tree shaking, ahead-of-time compilation, first compile-time built-in internationalization, and mature CLI-driven updates. So that said, Angular doesn't stay still or sit alone. So one of the things I've noted in the time that I've spent with this team is how humble, curious, and eager to improve the team is. So Angular is currently inspired by Svelte's authoring simplicity, Vue's approach to SFCs, Svelte stores and simplified state management, Solid's reactivity, React's unidirectional data flow, Vue's animations, and Aurora or Next.js's image component. So before we even go further about what's coming next, I want to talk about yesterday for just a second. You may have noticed, if you're paying attention to JavaScript communities, that Angular's external feature set halted for a few years. Calling into question by many, did Angular stall out? Well, actually, the team paused in many features due to Ivy. Ivy was a massive ground-up rewrite of Angular's renderer. Ivy was an exploration into how to build a framework that can evolve over time that was shipped in the last year. So you can liken this update to many of you React OGs might remember Fiber. React Fiber was changes to the reconciliation algorithm under the hood. And also, Vue recently did an update called Vue 3, which was rewritten in TypeScript and a whole rewrite of the reactivity system. So it is common for frameworks to do this kind of pausing, as Jason said, and kind of reimagining what their code base looks like from the ground up. These the hood rewrites have massive gains, but they have a trade-off that some of the work on the framework slows for a time. However, Ivy also brought with it great improvements: improved code base organization, better integration with IDEs like VS Code, significant speed improvements, and improved compilation errors. So that brings us to today. Now that those updates are done, Angular is evolving. And we are focusing on two major themes: advanced features and simplification of development. In terms of advanced features, Angular's been kind of ahead of its time in terms of updates and migrations, especially having worked on other frameworks, because it had to, because it is the #1 most used framework within Google. So some of those CLI updates had to exist in order to do the large-scale changes that are required to keep up Google's infrastructure. So let's dive into some of these key features. Let's say you're working along something, you're trying to debug something. Now when you get an expression changed after it was checked, you get a URL to angular.io for just the section so that you can learn more about that error. We now have runtime error codes. These error codes make finding references on how to resolve any errors you may encounter really easy. This also allows the build optimizer to tree shake these error messages into production bundles. Also, due to the fact that Angular runs at that scale that I mentioned, the upgrade functionality is very, very good. So we have ng update to transform a code base seamlessly, providing sophisticated error logs and reporting along the way. This means that Angular can continuously improve over time with smaller risk to users. Angular did learn from a breakage mistake between AngularJS and Angular, which is often the case when upgrades are backwards compatible. We have now created enhanced template diagnostics, which give great error detection, especially for common instances. For instance, one here is a binding error that we affectionately call the banana in a box, because bananas are arguably the funniest fruit. And other error messages include nullish coalescing error, tree shakeables, error messages, and Angular CLI also now offers autocomplete functionality as well, which keeps developers in the flow of their work. So in terms of other advanced features, we have strictly typed forms. One of Angular's nice features is built-in form validation. You don't have to add any other library. You can see how easily I write and build in reactive form validation in only a few lines of code and no external library or setup. However, in the previous versions of Angular, even if I wrote this validation, the type was cast to any. Now, that's a shame given the strength of TypeScript for this kind of validation. This was actually one of the most requested features on the GitHub repo. You can see almost 1,000 thumbs up on this issue. Oh no. But have no fear. In Angular v14, we added a feature that's both something that should have been improved and something way ahead. Angular already has built-in form validation, and now we leverage our first-class usage of TypeScript for strongly typed forms and validations as well. It is Angular's most requested feature, now shipped in v14. And that brings to the next subject, simplification of development. We're undergoing a massive movement to improve the developer experience of Angular, reduction of boilerplate, and making it easier to use. So an example of this is standalone components, which makes ng modules optional. What does that mean? A lot of you might not be Angular developers, so you maybe don't understand what ng modules are, but I'll break it down for you really quickly. Here's an example of a lazy loading component. Previously, in an ng module, we would have written our imports. We can get on to writing our routes and our routing configuration, which would go here. So today, we remove a ton of that configuration. So we can actually go from this to this. And this is just the first step. Angular is going through massive rewrites to simplify what people need to write in order to show the intention of the code that they need to produce. And that is something that we are continually learning and building on. So in terms of the future, after the Ivy migration, this year has been an avalanche of these quality of life features, and these improvements are just beginning. In 2023, Angular is tackling large developer experience gaps, rewriting a reactivity system. And what I presented today is just the tip of the iceberg and what's under development for future strides. So that's really exciting for the years to come. Also, I mentioned that this team is humble and hardworking. They do have a really large GitHub repo. Aside from that, the core team has grown, which has enabled the team to hammer down on technical debt. And this humble and hardworking team is really proud of some of the work that they've done. Taking 650 PRs down to under 100 is a huge, massive improvement and also pay down of technical debt. So coming up, you'll see a lot of great improvements, many of which I've mentioned before. Some of these are inspired by some of the other frameworks, easier and simplified API, and inspired by Vue and Solid and Svelte. improve performance, and update of the reactivity system, improve performance that works with Core Web Vitals and the Chrome team, better hydration for server-side rendering, better stack traces, better accessibility and better ARIA primitives, and a documentation revamp. Angular both pushes the web framework ecosystem forward and is also inspired by those around it. And this is how we all evolve. It is never in isolation. It is by learning from one another. Thank you.